Alright, so we know our slope formula is m equals y2 minus y1 and x2 minus x1. We know m is our slope because if we reference our definition of a linear equation in two variables, we know that it's the form of y equals mx plus b, where m is the slope, 0 comma b, the ordered pair, is the y-intercept, x is independent variable, and y is the dependent variable. And then it's denoted here because we know the slope and that y-intercept are constants, but just a side remark that m and b are constants, just so it's more clear there. So we know that m is the slope, and that's why this is the slope form. So if we take a look at a graph over here, let's draw a graph. And say we have a point up here, we'll call it x comma y. Now, we know that infinitely many points, or lines, are going to pass through this point, because they can go up and down, sideways, all sorts of ways. But if we have 2 points, we'll put it up here, x comma y, then that can only be one line that these points are a solution to, because you can't have more than one line. You can't have one going down because it won't hit this. But these are 2 different points, so we can't call this one x comma y and this one x comma y. They're both x values and they both have a y value, but they're not the same, so we have to denote that in some way. And how we do that is we use what's called subscript, and we'll call this x1 y1 and x2 y2. So this is no longer just some x values, it's now a specific x value, x1 and x2. So from there, if we evaluate the linear equation of this line, which we'll call y equals mx plus b, it's the equation of this line right here. If we evaluate this linear equation in 2 variables at these 2 points, we can rewrite this equation in 2 different ways. So if we evaluate it at x1 comma y1, we'll get y1 equals mx1 plus b. And if we evaluate it at x2 comma y2, we'll get the equation y2 equals mx2 plus b. We can do this because these 2 ordered pairs are solutions to this line. So now from here, we're trying to find the slope, but there's 2 unknowns in each of these equations. We have b and we have m. So what we're going to have to end up doing is getting rid of one of these terms so we can find the other one. So what we'll do, and how we'll do this, is we'll start by subtracting mx1 from both sides of this one and mx2 from both sides of this one. And we get y1 minus mx1 equals b, and y2 minus mx2 equals b. And now from here, because m and b are constants for every point on this line, m and b are constants clearly for these 2 points, so we know that the b is going to be the same. This b value is the same for both of these equations. Now because we know that the b value is the same, we can reasonably conclude that these 2 are equal at this point if they equal b. So what we could do is we can set them equal to each other, because we know that they're equal to each other if they both equal b. So we can say y1 minus mx1 equals y2 minus mx2. Now the b's gone, and all we have left is an m. And the reason we did this with the b is because the b is gone, and we didn't need the b because we're looking for m, which is the slope right here. So we can get rid of the b like that because it doesn't need to be in the game here, but we need the m. We could have done it with m, but then the m would be gone and we would have b, which isn't useful for us in this proof. So from here, we want to try to get the m's together. So what I'm going to do is I'm going to add mx2 to both sides. I'm going to subtract y1 from both sides. So I'm going to get negative mx1 plus mx2 equals y2 minus y1. Now from here, you can see we have two m's. And that's kind of a problem because, I mean, you only have one m here. So what we have to do is make this a one singular m. So how we're going to do that is we can factor out the m from here. So now we have one m and we get negative x1 plus x2 equals y2 minus y1. So now from here, we want to get the m by itself on one side. So because m is multiplied by this whole thing right here, and this can't possibly evaluate to 0, because in order for it to be 0, these two would have, x1 and x2 would have to be the same value, but they're clearly not, right? Because they're x1 and x2, they're two different values. So because of those two things, we can divide both sides by x1, negative x1 plus x2. So from there, we get m equals y2 minus y1 over negative x1 plus x2. And that's our slope formula. But you might say that that's not equal to this. But it is, because the order we add, remember, doesn't matter. So we can rewrite this as m equals y2 minus y1 over x2 plus negative x1. And that can simplify to be y2 minus y1 over x2 minus x1, which is what we have up here. And that's the proof of the slope formula.